Hello. Today we're going to talk about the vertebral column and the thoracic cage, also known as the rib cage. And as you can see, this is pretty important to chiropractors. This is a picture from 1956 where they actually had a beauty pageant for the best looking spine. And I also found this image online and I love it, the difference between a regular cane and whatever that type of a cane is. But if it were me, I think I would prefer that my spine had this arrangement. Because if your spine was here, it'd be going through your lungs. Yeah, so our spine should be on our back like this. That really doesn't make any sense. Um, yeah, and this diagram is on Canvas, so it would be helpful if you printed it off and then you can like fill it out while we talk about it. First things first, can we just like observe that spine, please? So this is a view from the front, and then this is a lateral view, like a sideways view. So first thing I want to point out is the spine a straight line? No, like it has all of these curves inside of it. It's supposed to curve in and out like that. I wonder why it has these curves. It allows us to be flexible and to be able to bend back and forth. If it was like a rigid pull, you wouldn't be able to move. But like think about all of the motion that we can do with our spine because each vertebra is separate. Also, review is that most of the vertebra have discs in between them. Remember those like fibrocartilage discs? So that also is helping the mobility there, letting it move back and forth. And again, function of the vertebra is to protect the spinal cord. The spinal cord is this yellow thing sticking through there. So it's there to be able to protect the spinal cord. Vertebrae normally have lots of processes sticking off of them, like lots of pointy parts. I wonder why. Generally, whenever we see something pointy sticking out, it's because a muscle attaches to it. You can also see like how these points like fit together really well, and that helps our vertebra like not get out of alignment. Like if I try to turn it like this, I can't because the bone is locked in place. So, pretty nifty divine. The colors on this image represent different regions of the spine, and you might remember them from when we talked about like our anatomical terminology. Top region is the cervical spine. The cervix, like cervical means neck, and if you remember, like the cervix is considered the neck of the uterus, which is why our, actual neck also gets described as cervical. And each of the vertebrae are numbered. So like this one at the very top here would be C1, C2, C3, C4, C5, C6, C7. When I look at the cervical vertebra, I notice that they're small and lightweight, and they have pretty small processes, like compared to the other ones that we're going to be looking at. Next section is called the thoracic vertebra, and thoracic means your thorax is like your rib cage, like where your lungs and your heart are. And the thoracic vertebra are special because every single one of them connects with a rib. So we have 12 ribs, we have 12 thoracic vertebra. And here is my cervical vertebra, and here's the thoracic vertebra for some comparison. So we can see that the thoracic vertebra is bigger because it's bearing more weight and it's starting to have longer processes. So thoracic. Your low back is called your lumbar spine, the bottom 5 vertebrae down here. These guys are gigantic because they bear most of the weight. Like if you can think your whole upper body is like being held up by your low back. And there's 5 of them. And let's see if I can hold these up all in the same view for you guys for a comparison of cervical, thoracic, lumbar. Also, an easy way to be able to remember which is which is they're kind of like meal times. Like 7, 12, and 5 is when you eat your breakfast, your lunch, and your dinner if you're an old person. But that might help you remember the number of vertebrae. And then down at the bottom, we have vertebrae that are actually fused into one bone called the sacrum. It's like your hip bone. So this is the front. And then at the back, we're seeing the lumbar vertebra. And then this whole part right here is the sacrum. The little teeny part on the bottom is the coccyx. This is our tailbone. It's basically a vestigial bone, like it doesn't really serve a purpose in us, but in animals that have bony tails, they would have more vertebra going out there and actually forming the tail. For us, the sacrum is important because it literally forms the back of the hip. Like if you think about this, let's look at it from the front, and maybe that's even a better view of how the sacrum is forming the back of my hip. Ooh, and a few special notes about the top two cervical vertebrae. If you know your Greek mythology, this is Atlas, and he supposedly holds up the weight of the world on his shoulders. So the top cervical vertebra is named after him because it has to hold the weight of our head on its shoulders. And I want to talk about C1 and C2, the axis and the atlas, because they don't look like normal vertebra. Like, look at that picture. You don't really recognize them. Vertebra are supposed to have like a big body and processes sticking off, and these guys just look funny. Anytime that something has a specific structure, there must be some sort of functional connection. So here's C1 and C2 fitting together. C1 is the atlas, and it's able to rotate like this. So like I'm nodding my head up and down to say yes. Right now I'm moving my atlas. If the atlas wasn't shaped like this, I wouldn't be able to nod my head up and down. And then C2 is the axis. It has like a knob. It's called the dens. It's this middle part right here in our image. That knob acts like an axis and it allows the atlas to spin on it. So like it can go like this, and that's like shaking your head no. So I'm able to shake my head no because of the dens on my axis that allows it to spin. So pretty cool structure function relationships. Also, for comparison of what some vertebrae actually look like, remember that these are irregular bones, and we can see the spongy bone here is like a nice view of it. That's where the spinal cord would be, and a little teeny one with some cobwebs in there. Okay, the other thing that I want to talk about today are the ribs. And I'm going to bring this picture up to full screen to make sure that you guys can see what I want you to see for this part. So let's use a little skeleton and see if you see that. So we have 12 ribs. I know that we have 12 ribs because we have 12 thoracic vertebrae, and each one has to attach to a rib. And like if you notice, like this is the rib, and then that slightly yellow part is that hyaline cartilage, the costal cartilage. And so all of these ribs connect directly to the sternum right here by that cartilage. The ribs that connect directly to the sternum are called true ribs. And then if we take a look down here, like these little ribs don't connect indirectly. If you see, they actually join in with that cartilage. So this, when it doesn't directly connect to the sternum, those are called false ribs. And down here, have you ever thought about this before? We have two ribs on the bottom that don't even have cartilage on them. So these are definitely false ribs because they don't attach, but they're also called floating ribs because they're floating. So one more time, let's try to count this from the top. That would be 1, 2, 3, 4, 5, 6, 7. So the first 7 ribs are true ribs because they connect directly to the sternum. And then here's 8, 9, 10. Those are false ribs, these bottom 3, because we have an indirect connection. And then 11, 12 are false ribs, and they're also considered floating ribs. And I'm also going to mention, if you didn't hear me say it before, this is your sternum or your breastbone. It gives a place for the ribs to attach to, and it also lets your collarbone or your clavicles attach to them. Here's a little pointy process, the xiphoid process made out of hyaline cartilage. I wonder why we have something pointy sticking out right there. It's for muscles to attach. The abdominal muscles don't really have anything to attach to, so they rely on the xiphoid process. Here is a labeled picture of everything that I just tried to explain to you. And I think that's it. I hope that that makes sense. I have a couple of ribs that we can look at together. If you were here, I'd get you to kind of try to sort them and see which ones go where. Thanks for watching.